My name is Paul Wolliver. I'm the owner of Pinellas Power Products, and I have developed a modification for bumper winches commonly found on four-wheel drive trucks and other applications. This modification will work with both the hydraulic version and the electric bumper winches. What my modification does is it makes it a two-speed winch. If you've ever used these winches before, you know that they pull really hard. They're very powerful, but they're also very slow. And it makes it frustrating to wind the cable or rope back in. My modification leaves the low speed, high torque the same, but it adds a direct drive or high speed that's strictly used to rewind the rope. Let me show you how it works, and then we'll go inside and I'll show you how I did it. The first thing is the low speed clutch mechanism had to be modified. Normally it's spring bound so that when you release this, it engages into the low speed. I had to reverse that because you don't want it to accidentally be in low speed and high speed at the same time. So I've reversed the low speed, so now the spring disengages it, and to engage it, I've got a key, and you can make this out of a bicycle spoke or an Allen wrench or whatever. But you push in on the clutch dog, and then you push the key into place, and it holds it in low speed. Now I'll go ahead and start this up, and when it's running, it'll be making so much noise you won't be able to hear me. But at any rate, I'll show you how it works in low speed. If you look out this way, you can see the rope is stretched out, and there's a piece of cardboard with the hook embedded in it. I'm going to go ahead and engage the low speed again so you can see just how painfully slow it is. And once again, that was the low speed. So that was the low speed, high torque. In order to engage the high speed, low torque, you'd push down gently on the release clutch and pull the key out. Incidentally, I used a 3.5 millimeter Allen wrench as my key. If I were to do it all over again, I would use a 4 or 4.5 millimeter Allen wrench. It's just a little bigger, a little bit easier to use. So now to engage the high-speed low torque, we slide the Allen or key into this little tube, and then we rotate it backward to where it goes underneath the lock pin. And now we're set for high-speed operation. And let me go ahead and start the tractor up, and I will recoil it. This is a hydraulic winch. So the neat thing about that is we can slow it down a little bit by not pulling back as hard on the hydraulic control valve. But let me go ahead and reel it in a little bit for you to see how it works. As you can see, the high speed is much faster than the low speed, and that allows you to reel in the line. It is not good for pulling because I used a 3.5 millimeter Allen, and like I say, if I had to do it over again, I'd use a 4 millimeter Allen. So at any rate, that's how the system works, and now let's go inside and I'll show you how I did it. The first step to doing this modification will be to pull this end housing off. and I mean the entire end housing. And that's done with just these 3 Allen screws. And this end plate and the hydraulic pump will come off in one unit. Okay. This one brought the main shaft out with it. The main shaft slides right into this socket. You'll notice it has a hex cut on this end. Now, some of the winches will come with a hex main shaft, or main shaft that's hex all the way. Others will have a hex just at this end and a round main shaft, like this one is a hex just at the end, and the rest of it is a round main shaft. On my particular winches, the hex main shaft was on the 15,000 pound and the round main shaft was on the 20,000 pound. I don't know if that difference is strictly that in the later model winches, like this one is newer, if they went to the hex main shaft because it was cheaper than making a main shaft that was hexed on one end and round on the other. I simply don't know. But at any rate, the procedure is going to be the same regardless of which main shaft you have. Okay, so once you get the end housing off with the pump, the next step will be to slide the spool off of the winch. Excuse me, winch as opposed to winch. Hopefully that doesn't roll away on me. What we need to do is modify the release mechanism. When it's in stock form, this would be engaged and this would be released. But we need to modify it so that it will automatically disengage where they've got it set so that it'll automatically engage. What they have is a spring pulling down, and let me show you. Here is the ring gear out of the 20,000 pound winch. And here is the housing, and you can see they're identical. And what this does is the ring gear sits in the end of the housing and it can either spin freely, or if the plunger pin is pushed down in, it will engage in one of the recesses so that the ring gear does not move. And here's what the recesses look like. And this is a spring-bound pin that'll push down into it. And that would be the stock configuration. So what we need to do is we need to make the spring disengage it and you manually engage it, so that you would either manually engage low gear for pulling or manually engage the direct drive for respooling your line, and that way you won't accidentally get it in high gear and low gear at the same time, because if you put it in high and low at the same time, something is going to break. Okay, in order to modify this so that it automatically disengages instead of automatically engages, first step is simply unscrew this housing. You can take it with a pair of channel locks or vice grips or whatever, and just unscrew it. And here's how it works. you've got a hex, or in this case a double flat shoulder that the handle will ride up on, and that is in the disengaged position. And you'll see that the plunger is just barely protruding from the housing, where when it's in the engaged position, the handle will slide down and the plunger will advance a little bit farther forward. And that's what allows it to engage into the ring gear. So we're going to go ahead and take our housing apart, and that's done by pushing this roll pin out. Okay. I've got the housing disassembled. The first thing I'm going to do is bore this end of the housing, and that is because if you notice, originally the engagement pin has a lot of play in the ring gear. So in order to get the heaviest grade or strongest system I can get, I want to get a larger pin. And since we're going to have to make a new pin anyway, and it has to be longer, I might as well make it a larger diameter. And in order to make it a larger diameter, I've got to bore the housing. So I'm going to start with a grade 8 bolt, because a grade 8 bolt is probably the highest quality steel you can get real quickly and affordably. Okay, so now I have bored my housing about as far as I care to go, because I don't want to weaken the housing by taking this too thin. So I've bored it just as large as I can get. Unfortunately, I didn't videotape it because I got, well, I messed up. If you have a lathe, you already know how to use it. You already know how to bore housings and so forth like that, so it's not a big deal. And if you don't have a lathe, you'd have to take it to a machine shop to have it bored, and the person with the lathe would again know how to use it. So it's no great loss there. So now what we're going to do is we're going to make a new plunger shaft that fits just barely inside this, so it's held straight, but we want it to be longer. So let's go ahead and get started on that. Okay, so we've got our grade 8 bolt, and what we're going to do is we're going to turn the bolt down to where it becomes fully round, and we want the bolt to be just able to fit inside this sleeve. So we'll go ahead and get started on that now. Okay, so now we've got our grade 8 bolt turned down to where it's perfectly round, and it slides into the bore that we bored our housing out to. And it's a nice snug fit. I'll go ahead and show you. Now it's actually going to go in from this direction, but as you can see, it is quite a bit larger than the original one. And it's now long enough that we can take the spring that used to be inside here, pushing it down, and we can use the spring to push it up. Okay, what we've just done is we have bored a hole for our key or lock pin. You'll see right here. And what this does is it allows us to either push this in and push our key through this hole to lock it into the low speed, high torque position, or we can remove the key from this and put it into the spindle and lock it into the high speed or direct drive position. But at any rate, with that, we won't have the problem of the winch accidentally being in high speed and low speed at the same time, because that'll break a lot of parts. Okay, so now that we have our housing board and our new plunger shaft, what we need to do is determine exactly where the hole in our plunger shaft needs to be in order to lock into the housing. So, put our washer on it, go ahead and screw it in. Now what I've done is I spun the ring gear so that the recess is lined up, so I don't have to spend a whole lot of time looking for it. Okay, let me get a scribe, because this is pushed all the way down into the recess now. So what I'll do is I'm going to scribe right at the top, and I'm not going to scribe all the way around the bolt here. And then I will go into the side, the hole, push my scribe in, and spin the bolt all the way around. And what that does is that tells me that the hole that I have to drill through the bolt is at the height of the line that's scribed all the way around. And that way I don't get confused when I go to drill the cross hole. So then our key, made from a bicycle spoke, will slide through and all the way through this shaft and come out this way. And when it's engaged, it will lock it down into the ring gear. So now you will see that we have a hole bored through our pin. Let's take it back over the workbench. So now let's go ahead and assemble our new lock mechanism. So we'll put the pin into the housing. Then I'm going to put a washer in our spring and another washer. And just to keep this shaft from spinning while I screw the knob on, I will go ahead and put the pin into the hole. So that locks it all together now. Now we'll take this knob and screw it onto the threads of the bolt. So now, when you push down on this, it advances the shaft. So what you do is you would push down. Now this is with it installed. You'd push it down to where your pin lines up. Then you'd push your pin in, and the plunger would now advance into the recess in the ring gear. So let's go ahead and install this in our housing. So this would be the released position, and when you push down and put the pin in, it's now in the locked position. And I'm going to turn this just a little bit more so that the pin is exactly 90 degrees. I think that'll be easier for me to remember while operating it. So pull the pin out, and it's released, and you can now push the pin into its final position in the spool, so it will be in a direct drive or in the low gear position. This is our spool, and what we're going to do is we're going to grind off just a small bit of this weld so that we can take a section of brake line, and we're going to cut it and weld it along the flange of the spool. And what that's going to do is allow us to push the bicycle spoke / key past the cable or rope. So what we'll do is we'll grind off a bit of this weld, and then we will drill a hole into the spool, and then we will take our section of brake tubing, slide it into the hole, put a notch right at the end so that the flared end will actually work to our advantage, and it makes it easier to put the key in when you're working out in the field and you've got either rope or cable wrapped around this. So let's go ahead and grind the weld down, and then we'll drill our hole. So I've drilled the hole, and I've ground just a slight notch into the flange of the spool so that it has an even lower profile, so it will not disturb the rope or cable very much at all. So now when there's rope or cable on it, you'll put the key into the hole, and it will engage with the ring that we're going to be making later on into the main shaft, so that it'll lock the spool to the main shaft. So what we do now is we go ahead and weld the section of brake tube into this position on the spool. Okay. What we're going to do now is make the inner hub that goes on the main shaft, and I'm going to be making it out of PVC, because all this is for is a high speed to re-spool the rope. And this way, if you're leaning forward and you push down on the engagement for the low speed, and you've got the pin in for high speed. It's going to be in both gears at the same time, and it'll tear up this plastic spool or plastic hub before it does any really expensive damage. So what I've done is I've just taken some pieces of PVC and glued along, made it thicker, and I will have to bush this down on the inside too. But let's go ahead and finish cutting this outside radius to where it goes just inside the spool. Okay, so now we have our, I'll call it a plastic drive hub. What we're going to do is take a section of pipe and a flat washer and weld the flat washer to the pipe, and then cut the pipe flush on this side and the depth of the drive hub on this side, and then we'll press it in so it's a nice tight fit. So let's go ahead and do that. Okay, so I've got the piece of tubing welded to the washer, and I broached it to a hex. If I were doing the winch with the round shaft, I would just drill a hole in the side of it and put a grub screw in it. But since this one is a hex, it seemed easy enough to just go ahead and broach it. What I'm going to do now, before I press this into the drive hub, is I'm going to drill some holes in the washer for index screws, so that when I press this in, I can run a couple of screws into it too, so that the nylon drive hub will be very well connected to the metal sleeve. Okay, so here's the drive hub on the hex shaft. So next thing I'm going to do is measure where this drive hub is going to sit and put spacers below the drive hub and above the drive hub, so it doesn't slide back and forth, and that way the row of holes that we're going to put in this will stay in place. On the round shaft, what I would do is, instead of making this washer flush with the end, have the pipe that I made it from stick out a little bit and just put a grub screw in the round shaft, and that would keep it from spinning on the shaft and keep it from sliding up and down. But I didn't think about that when I was starting this one, so we'll do this one with spacers below it and above it, and then whenever I do the round shaft on the other winch, I will just put a grub screw in it. So at any rate, we'll take the spool, and what I'm going to do is measure from the end of this gear to the little fitting that we put in it that the key is going to go into. And we're going to measure how far the offset is. So what we're going to do now is determine whether or not we need any shims between this hub and this gear in order to have the center of this drive hub line up with the keyway on the spool. So what we'll do is we will put the spool in place. Then we will put this hub onto the shaft. And just as a guess, I'm going to set it just a little bit shy of 5 inches down from this E-clip. That's 5 1/4. It's 5. 4 3/4. So I'm going to slide it down in there, and then I'm going to push this gear against the other gear. Then I'm just going to push something sharp into this and spin the spool to scribe a line. Okay. Now when we pull our main shaft and hub out, there should be a line scribed where we need our row of holes drilled, and there is. Just making a mark that'll be clearly visible when I go over to the mill. And let's see where this ended up. Probably about 5 to 5 1/16 of an inch. Ooh, we're at 5 1/8. So with the washer, we could cut our spacer at 5 1/16 of an inch. So now what we're going to do is drill our holes into this hub that our key will engage in when we put the key into the key slot. Okay, so what we're going to do now is drill holes around the edge of this. And we don't need it punctured full of holes. The low speed gear has only 4 holes around it. So if we put 8 around this, we're well ahead of the game. Just making sure that our key is going to fit in here. I think I'm going to make that hole a little bit deeper. Okay, we've got our main drive hub with all our engagement holes drilled. So now I'm going to put the flat washer and the spacer that I cut to 5 1/16 inch. And then we'll put this in and test and see how close we came. Okay. Bingo. Get our actual key now. And there we have it. Mark the length of our key. Wow, key needs to be exactly 3 inches long. Now go ahead and grind this off to a little bit of a point. Okay, so our key lines up perfectly the very first time out, which is rather unusual that something works out perfectly the very first time. Okay, so the last step before we put this thing together for the final time is going to be to drill a new hole for the anchor for the cable or rope, because if you use the hole that's right here, your rope or cable will wind this way, and then when it comes back this way it kind of leaves a cobbled up mess. So I'm going to drill a hole into the end here so that it'll be bolted to the end, and then as you wind it, it'll go all the way across and all the way back and so forth. Now we'll go ahead and tap that out. Now that it's drilled out to a 17/64, I'll tap it to an 8mm by 1.25 pitch, which is the same thing as the bolt that originally went into the drum. Okay, so now that we've got the hole drilled and tapped for the anchor point, what I'm going to do is I'm going to set the drum in place and then spin it and find out how deep I can put that screw in without it hitting the webs here because that's something I'm going to need to know later when I go to wind the cable on it. And there it is right there. Okay, so I need 7.21 millimeters of thread showing. So if we back it off to where there's 7.5 millimeters of thread showing, there's a margin of error. So I have to remember that when I put the rope on here, if this is less than 7.5 millimeters, I need to put a washer to keep this bolt from hitting the webbing. So now, we can go ahead and put this together for the final time. Tighten it all down. That's one nice thing about using the rope. At least the winch is lighter weight. Not that you have to lift it very often, but boy, when you do, these things are rough. One more thing before I forget. These end housings are aluminum. I have no idea why they made those aluminum. Everything else on this thing is made of steel, including the drum, the planetary reduction gear housings, the hydraulic pump. Everything else is made of steel. If they'd have made the mounting brackets out of steel, that would have increased your options on how to mount it, because then you wouldn't have to worry that this cast aluminum could fracture.